All right, pulling everything together. We're 2 minutes past, and we are in the last section. This is good. We're bringing everything together. One extra piece of information. We've talked a little bit about this, is there are CPU limits by addition. We did bring this up a little bit in our virtualization. It is worth knowing that for standard addition, we are limited to the lesser of 4 sockets or 24 cores physical, if depending on how we're doing our licensing. This is standard addition on physical hardware. If we are using a VM with standard addition, then it counts just the logical processors. It doesn't care whether we have hyperthreading enabled on the host or not. So if we configure our VM to show more than 4 sockets and we have standard addition SQL Server, we'll just be like, oh, I can't use those. Same thing with the logical processor. So we need to make sure that we configure the socket core ratio in our hypervisor in a way that lets us actually use them if we are using standard edition. For enterprise edition, we are limited to, and this is okay, what this is, if we are using a legacy agreement that got upgraded, that is called a CAL licensing. And it will be limited to 20 cores physical or 20 logical processors virtual. So if you look at your SQL Server startup log and it's like, I am only using 20 cores because of licensing reason, it is probably because this was installed. I have run into multiple cases where people paid for enterprise core licensing, but accidentally someone downloaded the wrong install files from Microsoft. They downloaded the one that was for this legacy agreement, so they were not getting all the processors they paid for. And you would recognize that by looking at how many cores does Windows see, how many cores does SQL Server see, like that queries we ran against sys.dmos info. And if those don't match, you've got one of these two going on most likely, or somebody configured affinity masking, I suppose. There could be some other thing up, but most likely one of these two things. Generally, Enterprise Edition and Developer Edition should use the operating system maximum. It now looks like a crazy football play. The older advice that you'll see from Microsoft is that 8 is a magic number. So that this is the older advice, and this is not always true anymore, but for older versions of SQL Server, they recommend that if you have less than 8 logical processors per NUMA node, and you have a single NUMA node, you set MAXDOP at or below the number of logical processors. So in other words, I have one NUMA node and I don't have more than 8 processors, so I would, go 8 or below. If I have multiple NUMA nodes, they recommend that you set MAXDOP, so let's say I have 8 processors and I have 2 NUMA nodes, so I have 4 each. They would recommend going at 4. You want to look at the NUMA node, the number of processors there, and go below, at or below. If you have more than 8 logical processors per NUMA node, they said that you typically don't get better performance at 8 or above. If the number of 8 sounds familiar, it's because we were talking about this with automatic soft NUMA. The reasoning behind this had to do with the fact that at value, we had difficulty scaling beyond 8 processors. Those processors are going away. This advice is no longer current. But if we add in workload type for the old advice, we do also need to think about, okay, so you're saying 8 or less, right? Well, how do I know 8 or less? The general advice is to look at your workload type and say, do I have an OLTP style workload? If so, I want to be a lower DOP, like 2 or 3 or 4, because I have a lot of little queries running. I don't want them to use all of the cores because I don't want them to fight over the cores. If I have a data warehouse style workload, the idea is I have fewer cores that use more queries running, let them have a higher DOP. This is all messed up now. This advice is no longer current because most of our workloads are no longer pure, and we have a mixed workload. Traditionally, the way to solve this is lower DOP, use some hints to go higher, but that isn't, maybe I think now better advice is higher cost threshold. Configure my DOP based on testing, but this can work to have a lower DOP, have some hints to let some things use higher DOPs. Again, it's more of how you want to tune it, but yeah, this advice isn't so magic anymore because even Microsoft, so this is an article from the PS SQL Server team. I believe this was written by, I can't remember if it was Bob Dorr or Bob Ward, but they did some testing with the AutoSoft NUMA, and what they found is going over 8 was better. That old advice of the old device was basically you're unlikely to see improvements over a DOP of 8, and that's just not true anymore. In this case, they did set the DOP to the number of physical cores on a socket. This was not a virtual environment. It was automatic soft NUMA that is hyper-threading aware. In other words, it was seeing on the physical hardware, how many cores do you have? And they got on a highly concurrent workload, not just testing a single query, but a highly concurrent workload, they got a significant performance gain from partitioning the access to those highly concurrent user structures there and setting the degree of parallelism to a value higher than 8. So this, if you have newer gear, if your servers are not 5 years old, if you're using more recent versions of SQL Server, those are the ones where I would definitely test higher values than 8. If we're running SQL Server 2005 on really old hardware, that may not pan out, right? I still like 8 as a starter value. You know, I would, and looking at, I should say on this slide, the number of physical cores in a NUMA node does still matter. So 8 can be a good starter value. Obviously, if I only have 4 logical processors, 8 is a ridiculous starter value because it's just going to go with 4, right? So assuming I have more than 8 logical processors, I do think 8 can still be a good starter value. Testing up to and even beyond the number of logical cores in a socket can make sense too, because we may get better performance at higher DOPs. But of course, for what we really want to know is for the biggest workload, for the biggest queries in our workload, how do they test? Not just any old query, because different hardware and different queries will do things differently. Before I devote a lot of time to it, I want to make sure that power savings is not enabled in the BIOS of the host servers. So if I'm running directly on physical hardware, I want to check it on that server. If I'm virtualized, I want it checked on the hosts. Don't waste a lot of time tuning MAXDOP if you're not getting all the speed out of the cores possible. This is not just a Windows setting. You need to check in the BIOS of the server if it has power settings disabled. And many servers do ship with this enabled. You need to make sure it is, you look up a performance guide for that hardware because the settings are different depending on manufacturer, but you really want to make sure those are off because it can slow down. You could do a bunch of testing and the results might not be valid because, oh, we were actually waiting for the power to kick in on our CPUs. That was why it was slow. It had nothing to do with DOP. Oops. When I change this, I like to usually move by 2 is my preference. If I have a server with a lot of cores, and I might make bigger jumps, depending on, especially if I have a private testing period and I'm not going to impact everybody else. If I'm having to change this on a live server, I usually do small incremental changes, both for MAXDOP and for cost threshold, and burn in the changes over a week. When I say monitor, I'm monitoring query duration there. How do we confirm the power settings on the VM host? I have to rely on the server team for that. Yes, this is a fun game. So usually what I ask for is, do you have a screenshot of the current power settings in the BIOS for the host? So that is what I will ask for, is a screenshot of the BIOS settings for it. Because when you set this, it's in the BIOS. And if they don't have a screenshot, I ask, can we get one during the next maintenance period? This is kind of a political game because what I don't want to do is I don't want to just ask them how has power savings been disabled, because they will just say yes. So I ask for, and I say, we want to, and I usually, so when I've come in, especially as a consultant, I say, we want to include this in our documentation for the servers. If we don't have it yet, could we get it during the next maintenance period when the restart is planned? And I may have to wait for it, but I do try to ask for it that way. And I try to say it's part of our run book, you know, and it legitimately is part of our documentation, but I try to do it that way just to make sure that I know what the configuration is. But yeah, it's lots of fun playing that game, isn't it? It's lots of fun playing that game. That is one of the, working with computers is terrible. Working with people, working with computers adds an extra layer of complexity on top of it. It's not the people that are terrible, it's just the computers, but it just adds an extra level. As we've discussed, changing MAXDOP can change our execution plans, and we have looked a lot. I monitor both query duration and their worker time. I do wish that if it was a game to make the CX packet weights go away, our life would be easier, but I don't think it's quite that game. I like to document all of these things. These are not the only things to document, of course, but these are the things that it can be really tricky to know. Like these two settings in particular can be really, really sneaky. We also want to know things about the cost threshold. It's just easier to see the cost threshold and the instance MAXDOP setting. If we're using anything special like lots of hints or database or resource governor settings, I would put that right in there. Martin says, does vCenter show you that info for VMware? I haven't looked at that in a long time in VMware. Used to, I don't think it did show that BIOS info, but I could have some out-of-date knowledge on that one, unfortunately. So that is a great question. I know that it used to not. They change it all the time. It is all the time. So there is a Windows policy as well. In Windows, there is power savings here. So let's go back to our VM here. In Windows, come on, Windows. And even let's go to, this is my host machine here. In my host here, there is power savings that I can look at and power plans. The problem is these, and I don't even know what operating system is installed here at the moment. But if I'm like, this is not a server operating system. I want a server operating system. The problem is even in the server operating system, the one that Windows policy can look at, I could disable power savings in Windows. It will not override the setting in the BIOS. Wah, wah, wah. It's sad. So we could have power savings disabled even on the host machine in Windows if it's running Hyper-V, or even in the VM, and then there could still be power savings going on based on the server settings in the BIOS. There's also weird things that can happen too. So for instance, there's one case I saw where CPU usage was just really high, like really high. And you'd run like a small query and you'd see all this CPU usage. It was really weird. It turns out that one of the power sources wasn't fully plugged in the physical server itself, and that when the power supply was properly connected, CPU use dropped. It essentially just wasn't properly powering one of the physical CPU cores, and it caused high CPU usage, which was because almost everything was using just half of the resources on the server. It was bizarre. So one of the nice things about virtualization actually is in a case like that, you might notice, hey, we get really different performance metrics when we're on different hosts. And you actually might be able to more easily narrow down something like that and figure out, hey, there's something wrong with this host because we see very different baselines when we're on different hosts. So that's actually one thing virtualization can help with. So example instance, if I had 64 cores with hyperthreading and I had 2 NUMA nodes and I was running on virtual hardware with a mixed workload, I might start for a new server. I might start at MAXDOP 8 and cost threshold 50, just because those are my personal kind of comfort zones. I then want to do big baselining and see either through query store, or if I need to use the execution plan cache just by periodically checking and recording. Here are my biggest queries by total CPU usage, and here is their CPU and duration. I'm going to look at their plans and see if they're getting parallel. And we have some sample queries in that script there. And then see, do I have top queries who aren't going parallel and they take a long time? What's their cost? What's their cost at DOP1? Are they using parallelism inhibitors that we cover? Like, why aren't they going parallel? Why aren't they? Like, it might indicate I need to lower my cost threshold. But also, just why are they slow if they're costed under 50? Are they under costed? If I have frequently running queries who go parallel, who look like they may not need it, I look at them and I'm like, oh, you're going parallel and you're doing like 2,000 logical reads. Do you really need to go parallel if you're doing 2,000 logical reads? That might be a good case for raising cost threshold even higher. I might test a few of them and say, oh, if I run you with MAXDOP 1 hint against the test system, are you still fast? If so, cost threshold going up, going up, going up. So looking at, for your top queries, looking at, total CPU time, total logical reads can kind of help you guess, can I go higher with cost threshold? Once I've got cost threshold where I'm comfy and I'm happy who's going parallel, then I want to know, okay, is raising, for the queries who are still going parallel, will they be happier if I actually let them use more cores? Because they may be faster at DOPs higher than 8. But I do want to be careful, because if I just let them use all the cores on the instance, then I might have still a lot of queries using a lot of cores and might, so I want to kind of gradually go up and look at what their duration is. I do want to check on my weights. I do want to see, hey, after this last DOP change, did CX packet weights go way up? Depending on my version of SQL Server, that might mean lower DOP might be better for me overall, right? So I wouldn't neglect other top weights either. This is a mistake that I've made. Like one case where we went to a new server that had a lot more memory and a lot of things got faster, but we had a lot of blocking problems all of a sudden because things changed because we had more memory. So I would still look at weights other than CX packet, like, hey, do I have something else creeping up? And then rinse and repeat. If I have a less critical instance, I'm going to be more, I'm not going to fine tune everything as much. I'm going to be more like, okay, here is our basic guidelines that we have, and I'm going to start with those. I'm going to look at the weights and make sure that I don't have CX packet weights like crazy, especially on, but the CX packet weight, I'm not going to freak out on before the new CX consumer was introduced, because who knows what CX packet means. But after 2016 SP2, if I have very high CX packet weights, I might be like, lower DOP might be better. But I'm not going to spend too much time on it. With the more critical instances, I'm going to kind of fine tune those top queries more. Does this theory also apply to dynamic SQL? I have a vendor app that doesn't use stored procedures. Dynamic SQL so it's possible, depending on how your vendor app is written, dynamic SQL can be great or it can be terrible. And a lot of it is due to the implementation. You can have parameterized dynamic SQL. It is possible for dynamic SQL to reuse execution plans much like stored procedures. And that would be the same. Even for non-parameterized dynamic SQL, the big issue there is that it'll generate a lot of separate execution plans and it won't reuse them. So you may not get as much reuse of the plans. Looking at your top queries is harder because you get separate entries for every different parameter value. So when you're looking at your top queries, what you want to know is, do they have parameters in them? Are they parameterized? And that will just, because if they aren't parameterized, everything will have an execution count of like 1 or 2, generally. So they are not parameterized, and that's what you're struggling with. One option for you is, this is a vendor app. You could ask your vendor if they support forced parameterization. They might allow you to change on the database a setting for forced parameterization that will make them, like, it'll try to parameterize them behind the scenes. It doesn't work perfectly for everything. It can't parameterize things like with wildcards or everything, but it can parameterize a lot, and that could allow execution plan reuse to happen, which makes it much more like a normal database. So you could ask, hey, is it okay if I turn this setting on? It's fully documented, fully supported by Microsoft, and just explain, hey, this code isn't parameterized, and Microsoft really recommends parameterizing your code. So you could test that to see if it could make your life simpler, because it will make your life a lot simpler in terms of figuring out how often is this query run, because I won't have to see it with different values for every single parameter. So hopefully that could help. Yeah. That's unparameterized dynamic SQL, though, is a really bad sign. Well, it's a sign of a lot of opportunities. Unparameterized dynamic SQL kind of usually means we didn't think about what we were doing at all. So you probably got a lot of opportunities in that database. Yeah. Opportunities is the way to say problems, right? All right, well, we went to 1221. Are there other questions folk have? And if questions come up for you later, you can completely ask. The course pages for this will have comments enabled, so you can ask questions on there, which will help other people who come along and watch it later. You could also ask questions in Slack if, for instance, I completely goof up and haven't put the scripts where I say I've put the scripts. Hopefully I do have them in the right place. Glad that you enjoyed it. Thanks so much for coming. But yeah, as the info sinks in, even if there's just like, oh, it would really help to have a blog post on what you said about CX consumer, I would love to have that advice sent my way, because I definitely am going to write a blog post on that thing about the minimum with the database DOP and the resource governor. All right. I used to say that friends don't let friends use resource governor, by the way, but I've had to take back that statement because resource governor, if you happen to use in-memory OLTP or even some things with column store memory or column store indexes, resource governor actually can be useful in terms of changing and monitoring. So for in-memory OLTP, it's very useful for configuring how much memory can it use and for monitoring it. And for column store indexes, it can be used for allowing queries to use more memory when they are doing something like creating a column store index. So I can no longer badmouth resource governor back and forth. I can say that resource governor will take up a lot of your time. Resource governor is like a time warp where if you start using it, you never know when you will get to exit. Thanks so much for joining me. Bye, folks.